Hello everyone, I'm Wazim. Today we are going to explore how computer systems work from the heart of the machine, the CPU, to the networks and technologies that connect the world. Whether you're curious about how your phone processes a selfie or how the internet streams videos, this session will give you a solid understanding. Let's begin with the CPU or Central Processing Unit, the brain of the computer. The CPU consists of four key internal components. First, the Arithmetic Logic Unit or ALU performs all the arithmetic and logical operations like addition, subtraction, and comparisons. The Control Unit manages how instructions are carried out, directing the flow of data between components. Registers are small, ultra-fast memory locations inside the CPU that temporarily store data and instructions during processing. And finally, cache memory. This is high-speed memory that stores frequently used data, helping the CPU access information quickly and reduce lag. So, what does the CPU actually do? It maintains its main function is to execute instructions from programs. It processes calculations, makes decisions, and manages data flow within the system. It also coordinates between memory and input output devices, ensuring everything operates smoothly. Think of it like a manager on a factory floor, directing every action and making sure each task is completed in the right order. A computer is more than just a CPU. Hardware components work in harmony to process information. The CPU does the processing. RAM or memory stores data temporarily for quick access. Storage devices like hard drives and SSDs store files long term. Input devices like keyboards and microphones send data into the computer, and output devices like monitors and printers present the results. All these parts rely on the CPU and communicate over the motherboard, kind of like organs in a body coordinated by the brain. Now let's look at the storage media. Hard disk drives are great for large storage at a lower cost, but they are slower. Solid state drives, SSDs, are much faster with no moving parts, making them ideal for performance. Optical media like CDs and DVDs are less common today but are still used for media distribution. And flash drives, like USB sticks, are portable and perfect for quick file transfers. Each storage type suits a different need, from archiving data to booting your computer. Now let's talk about how computers understand data. Computers operate using binary code, just zeros and ones. Every bit of data, whether it's text, numbers, or images, is broken down into this format. For example, text is encoded using systems like ASCII or Unicode. Numbers are stored in binary and sometimes displayed in hexadecimal for easy readability. Understanding this helps us see how flexible digital systems really are. With all this data being stored and transmitted, security is crucial. And that's where encryption comes in. Encryption transforms readable data into scrambled code, protecting it from unauthorized access. Only someone with the correct key can decrypt it. Common encryption types includes AES used in most secure applications, and RSA, which is widely used in secure internet communications. Encryption is the backbone of digital privacy. from messaging apps to online banking. How do computers handle images and sounds? Images are made of tiny dots like pixels. Each pixel holds color data, often represented in RGB values red, green, and blue. Sound is stored by sampling audio waveforms at regular intervals and converting them into binary. File formats like JPG, PNG, MP3, and WAV help store and compress these multimedia elements efficiently. Speaking of file sizes, this brings us to compression. Compression helps reduce the size of files, making them easier to store and transmit. Lossless compression keeps all the original data. It's used for documents or software files. Lossy compression removes less noticeable data and is commonly used for images and audio, for example, in JPG or MP3 file. Compression improves storage capacity and speeds up file transfers without losing much quality. Let's zoom in for a moment on how computers make decisions using logic gates. Logic gates are building blocks of digital circuits. They perform basic logical functions and, or, not, and so on, using binary inputs to produce a binary output. They are essential for CPUs, memory, and other components to perform operations and make choices. Now we move from inside the computer to how computers connect with each other through networks. There are several types of computer networks. LAN, abbreviation Local Area Network, connects devices in a small area like a school or office. WAN, which means Wide Area Network, spans large regions. The Internet is the most famous example. PAN, Personal Area Network, connects devices around a single user like a smartphone and smartwatch. MAN, Metropolitan Area Network, links multiple buildings in a city or campus. Each serves a different scale and purpose. What makes these networks work? Hardware like routers, switches, and network cards handle the physical connections. Software like network, operating systems, and communication protocols manage how data is exchanged. And transmission media like Ethernet, cables, or Wi-Fi signals carry the data. Together, these components allow devices to share information and resources efficiently. The World Wide Web is the part of internet we interact with every day. It runs on key technologies. HTML structures content. CSS styles it. And lastly, JavaScript adds interactivity. We use web browsers to access content hosted on web servers and HTTP/HTTPS protocols to transmit data securely. DNS or name system translates website names into IP addresses. All these elements work together to deliver websites, apps, and online services. And finally, let's talk about network topologies, how devices are arranged in a network. In a star topology, all devices connect to a central hub, common in home networks. A bus topology uses a single cable. It's simple, but one fault can crash the network. Ring topology connects devices in a circle with data traveling in one direction. Mesh topology interconnects every device to others, very reliable but more complex. Each layout affects performance, cost, and resilience. To wrap up, we have explored the internal workings of a CPU and how it works with memory and storage. We have seen how data is represented and encrypted and compressed. We looked at how multimedia is stored, how networks function, and how the web connects it all. These building blocks power the digital world we live in. Understanding them gives us a solid foundation in computer science and IT. Thank you.